Hello, students. We are beginning today our notes on our next topic in science class, which I find this topic fascinating. I love chemistry. I love physics too, but I love chemistry, and I love when we get into chemical reactions. The next few weeks should be rather exciting and entertaining as well as we explore our topic this week, chemical reactions. So let's get right into it. You've watched a couple of videos already that share with you some interesting chemical reactions, but let's explore what exactly are chemical reactions in the first place. Chemical reaction is different than a physical reaction. In the past, we've learned about physical changes in substances, in particular phase changes or states of matter, when there is a difference in the kinetic energy between one phase or state and another phase or state, solid, liquid, gas, plasma, etc. But today we explore chemical reactions. And a chemical reaction is a process that changes not just the physical, but also the chemical properties of substances in order to form new substances. So there are dramatic, sometimes, new changes taking place with the whole atomic properties, the elemental properties, the compound properties of various substances. It's more than just going from a liquid to a gas. After these couple topics, you're going to say big whoop-de-doo with physical changes because chemical reactions, these chemical changes, are, I think, much more interesting. Now, how can you tell whether or not a chemical reaction is taking place? Well, what we're going to be doing is learning about several indicators of a chemical reaction. An indicator is something that we are able to observe, whether with our eyes, our ears, our sense of touch, odor. We won't be tasting anything, of course, in the laboratory, but these indicators are things that are easily observed and will be clues or evidence for us as a scientific observer to determine whether or not a chemical reaction is or has taken place. So let's go through a list here of indicators of a reaction, beginning with a gas being produced. I'm going to show you little video clips along the way here of each of these indicators of reaction so that you get a better picture of what we're talking about when we talk about each one. So first, gas produced. Let's watch this video on a gas being produced so you can see what I mean.
So we just saw that as we went from 4 to 8 to 16 grams of sodium bicarbonate, each of the balloons got progressively bigger. Now let's take a look at the same reaction with 32 and 64 grams of sodium bicarbonate and see what happens to the relative amount of gas that's produced or the size of the balloon.
Do you think there'll be more? That's a lot of gas.
So after this reaction has completed here, we can see that the relative size of the balloon for the 32 and 64 gram sodium bicarbonate is roughly the same.
Now, he doesn't talk about this, but your question might be, why? And later in this topic, I'm going to explain to you why, but I'll give you a little preview right now. You see, we are not God. We cannot create or destroy matter. There's a law called the law of conservation of mass, which we're going to get to tomorrow, which answers the question, why does it just not get bigger and bigger? There are limits, and we'll talk about those tomorrow. But for today, just keep in mind that what you are seeing, the gas being produced, is an indicator that, in fact, a chemical reaction was taking place here between the acetic acid and the sodium bicarbonate, otherwise known as vinegar and baking soda. It's something you could do at home even without a balloon. Just put some baking soda and some vinegar into a container and fizzy, fizzy bubbles. That is an indicator of a chemical reaction. Here's number 2. The second indicator of a chemical reaction is a change in color. A color change can be an indicator of a chemical reaction. Let's check out this example of a chemical reaction indicated by a change in color. Chameleon chemical reaction. Oh yeah. Sounded like Tinkerbell, didn't it? Changing colors. Now, you may have noticed those different chemicals that were being added into the water there. Chemicals we'll learn about over the next couple weeks, but that change in color, back and forth, indicator of a chemical reaction. Next, number 3. Number 3, indicator of a reaction is light being released. Light being released from a reaction is an indicator that something is going on. So let's check this out.
Hi guys, my name is Jay Sakon and I'm a senior here at the University of Wisconsin-Madison. I have a demo here for you called luminol, and what I'm going to show you is a phenomenon called chemiluminescence. And what happens there is where you have a chemical reaction that produces light but not heat. You may have seen this before when you have a glow stick. You crack the glow stick and shake it up, you get a nice cool glowing phenomenon. That's what we're going to do here. So what I'm going to do is I'm going to take these two chemicals, luminol and hydrogen peroxide, pour them into this cylindrical little spiral spout here, and we'll see a nice glow effect happen.
How cool. Look at that.
Luminol actually is quite a toxic compound, but through this reaction, it's completely inert and you can flush it down the drain.
Now, can you imagine if that came out of you into the toilet? It would be safe to flush down the drain, but would it freak you out if you released something like that that actually glowed in the dark? Although that would be kind of cool, wasn't it? Just don't drink any luminol, folks. It could kill you. All right, so let's go on to the next indicator of a reaction, and that is heat being absorbed or heat being released. Technically, they're called endothermic or exothermic reactions, and we'll spend time on those two in particular in the future. But for now, heat being absorbed or heat being released. In other words, something getting colder or something getting hotter after you mix things together could be an indicator of a chemical reaction. So let's check out quick videos on this.
Hi, I'm Jared, and welcome to Fun Science Demos.
Hi,
the big
Jared.
idea? In a chemical reaction, a new substance is created. Something else is going on there. Temperature. Heat is actually created or taken away during that chemical reaction. How do we show you that? Our temperature probe. It's just a fancy thermometer, and I need a chemical reaction. I have two substances here to make that happen. I've already poured the vinegar in my beaker just to speed things along. So let's take the temperature of the vinegar. I have my temperature probe. I'm going to put it in there. And now with this setup, all I do is collect the data. And what I'm seeing here is pretty much a flat red temperature line. It's reading 17 degrees Celsius, and it's pretty stable, it's pretty flat, nothing's happening. So we said the big idea was that heat is either created or taken away during a chemical reaction. I need a chemical reaction.
Yeah.
Bring in the baking soda. Let's watch our temperature line as we dump in the baking soda. Not the reaction, the temperature. Here we go. We have our reaction, but stir this around. And I can see the little red bulb line on my thermometer just start dropping down. What does that mean?
I don't know.
It means my temperature's getting colder. That heat is being taken away because of this chemical reaction. I can see the new substance, but when that new substance is created, it's taking heat away. My temperature probe proves it. Science is so cool. Thanks for watching. So where do we get the temperature probe? This temperature probe is actually called GoTemp, and it's made by a company called Vernier. It's a great company that offers...
All right, we don't need the advertisement, right? So let's check out the next one dealing with heat energy being absorbed or released.
Today I'm going to show you an exothermic reaction. First, put steel wool in a bowl and cover it in vinegar. Allow the steel wool to soak for about a minute.
Be careful, kids.
Take the steel wool out and squeeze out any extra vinegar. Put the steel wool in another container and cover it in saran wrap.
Hey, we could do
You may
one.
begin to see fog on your container. Looks like things are heating up. An exothermic reaction is taking place. You can also get a thermometer and poke it through the saran wrap, and then poke it into the steel wool to see how hot it is. The iron in the steel wool is beginning to rust. Rusting, or oxidation, is an exothermic reaction. That means energy is released in the form of heat. Check out our blog for more information.
Well,
Check out this video for an even hotter exothermic reaction.
Oh my!
Thanks for watching Science Kids!
You're welcome, Science Kid. Now, he's a smart kid, isn't he? That is cool. So we have seen two quick examples of one endothermic and one exothermic reaction where heat is absorbed and heat is released, respectively. All right, let's get to the next indicator of a chemical reaction, and that is a change in properties of a substance. Now, we're just not talking about state of matter or phase of matter. We're talking about change in the properties of the substances themselves. So we've got another clip here to illustrate this. So let's check it out. Oops, there we go.
In the double displacement reaction of silver nitrate and sodium chloride, we have a solution of silver nitrate, which is colorless. We will add a solution of sodium chloride, which is also colorless. When the sodium chloride solution is added to the silver nitrate solution, a white precipitate, insoluble silver chloride, is formed.
Well, that was exciting, wasn't it? A precipitate, a precipitation reaction. When you add two liquids together and you end up with solids coming out of those liquids, it's like, wow, where did that stuff come from? A chemical reaction. So again, we've got several different indicators of chemical reactions. Let's just review them here again quickly. If you are mixing things together in the laboratory, chemicals of some kind, and a gas is produced, it could be a chemical reaction. If a color change takes place, it could be a chemical reaction. If light is released, it could be a chemical reaction. If heat is either absorbed or released, it could be a chemical reaction. And if there's a change in properties altogether, it could be a chemical reaction. So these are the indicators of a reaction. Be sure to study them, because in the lab later on, you will have to determine whether you are observing an indicator of a chemical reaction or not. So study hard, and until next time, I'll say bye-bye.